Hello students, welcome to Edubbey Global Solution. Now mathematics class, we're going to be looking at another topic which is collecting, displaying and interpreting data. In our previous class, remember we looked at mean, median, mode and range of data sets. So in this class, we have an interactive content that will serve as a guide for this topic, okay? Now we look at the very first thing here is tally charts and frequency table. So if you have a raw data set that has not been grouped and you want to group it to know the number of the frequency, that is the number of occurrence of a specific number, and we can also indicate that with a tally, that is a stroke, where one stands for a stroke and it goes like that, two for two strokes and so on and so forth. So we have an example here. The number of chocolate buttons in each of the 20 packets is, we have 35, 36, 38, 37 up to 38. Okay, the tally chart is indicated below us. Now look at what we have. Now this one is telling us that we have number 35 to 36 from this data that we have here, and our tally ranges that is, we have how many how many 35 can we see here? We have 1, 2, 3, 4. So that is, we have 1, 2, 3, 4, and the frequency is going to be 4. That's it. We can see only what 4 35. Okay, now for 36 we have how many 7. So one thing about tally is, by the time you count a stroke of 1 to 4, then the fifth one is going to be a slash, and that's make it a flat 5. Okay, so by this is 1, 2, 3, 4, and the slash is 5, then we count 6, 7. So that makes 36 to occur 7 times. And you count from here, you can identify 37 in how many places? 1, 2, 3. So 37 occur 3 places, and 38 occur 6 times. And that is how we can actually represent our information using our frequency table and our tally chart. Okay, now let's look at, we want to look at pictogram. From the word pictogram, you know that we are trying to talk about a picture. So in this situation, we are trying to represent our diagram with picture, okay? So this information that we have to calculate with us in each of the 20 packets, we have it labeled from 35, 36, 38, up to we have 37 inclusive as well. So we want to use our pictogram to illustrate this information. So if you look at this here, we have been with a full green circle. We have 4 packets. If you have a 1/4, we have 3 packets. Half is what? Half is 2 packets, and just one of the circle is what? 1 packet. So we have 35. Whenever you say 35, this is telling us that we have 4 packets. 36, we have 3 packets. Okay. So we have 4 packets and 3 packets. So by the time we add them together, 4 plus 3, that's 7. So we have 7 packets all together. And for 37, we have what? 37, we have just 3 packets. So we have 3 packets here. And for 38, we have 4 packets plus 2 packets. Okay, so let's add together 4 plus 2, that is 6. So we have 6 packets all together. Okay, now we are looking at bar charts. Okay, now what we're talking about bar chart. Bar chart or a graph is a chart that presents categorical data with rectangular bars with height or length proportional to the value that they represented. So when you're talking about bar chart, it presents your information, that is a category data, that is information specific. They have a specific set of information. It presents them using a rectangular bars, and that rectangular bars represents the height of those data sets. So if you look at this is an illustration here. So that implies that for that, the number of, it have 4 packets, right? So we have 35, we have 36 that have 7 packets, we have 37 from our previous information that have how many packets? 3 packets, and we have 38 that has 6 packets. So this one is just to denote the definition of what? Of a bar chart. Okay. Now we have stem and leaf diagram. I've made mention of categorical data in the other class, that is, you have a specific data set. Now, when you're talking about district data, they are talking about a fixed specific value. So these are data sets that has a specific fixed value, that is 1 is 1, 2 is 2, 3 is 3, and so on and so forth. So when we are talking about stem and leaf diagram, it can be used to display a discrete data in a clear and organized way. So we have an information here. The age of people on the coach transfer them from an airport to a skit resort are as follows. Okay, so look at the ages of those of the people that we are talking about. We have 24, we have 35, we have 18, we have 20, we have 29, and we have 33. The highest value there, I think, is 48. Okay, so with the stem and leaf diagram, we can easily identify the smallest, the middle value, and the highest value. So what stem diagram does is it splits our values into two. Okay, and starting from the smallest to the biggest. So if you look at this, we are having 1 to 4. Why do we have maximum of 4? Because the maximum value that we have here is 148. Okay, so the first one is 18, so it's split. So that means that we are reading, we have 18. The next one is going to be 20, 22, 23, 24, 24, 24, 24. We have 25, and we have 29. That is from this data set. Okay, so if you look at it, the next one we're having 31, 33, 33, 33, 33, 35, 36, 37, 39, and the next one we have 40. Okay, I think we should have another 40, 40 again. We have another 42. Okay, and we have 48. And that makes the arrangement of the stem and leaf diagram. So it splits our values into two and give us easy identifications of our district data. So from here, if you want to ask which of this person is the youngest person, so is the person with what age? So if you want to ask again, which one is the model class? The model class, that is the highest occurring. So the highest occurring there is what? Is 25, 24, 24 have how many? That is 4. Different persons that is 24 of age. We have 25, and we have also 33. They have 4 in common, and that's how stem and leaf diagram works. Okay, so we have back-to-back stems and leaf diagram. In this type of diagram, we can actually, the previous one we are just bringing in one discrete information. But when you're talking about back-to-back stem and leaf diagram, you can bring in two different information. So the first one here, we are telling us that the age of people that the coach actually transfer from airport to the skit resort, and the other one, the people that are coach are actually transferred from the airport to a golfing holiday. So we are going to be drawing this information using back-to-back stem and leaf diagram. It's just the same thing as stem and leaf diagram, but this time around we have two different information. So we have the first one on we have the second one on the left hand side and the first one on the right hand side, and we have sending numbers, which is what 1 to 7, that differentiate between the two. That is, the two of them are actually having this set of information. So the first one is having 18, the other one is having 28. We have skit for 20 up to 29, and Gob only have 28. Okay, so for skitting we have 31 to 39, and for Gob we have 43. Okay, 35, 36 to 38. So okay, for skitting as here we have 40 to 48, and for golf we have 43 to 48. We have 58 to 55, 52 for golf, and 61 to 69 for golf. Then we have 17 and 72, and this is just how to represent our district information using back-to-back stem and leaf diagram. But discover that this one is having two sets of data sets. Okay, now let's look at grouped data. If there is big range in the data rather, it is easy to group the data in a grouped frequency table. That is, the group are arranged so that no scores can appear in two groups. Okay, so we have the example here. The score for the first round of the golf competitions are from 71, 88, we have 102, 102, 75, we have 72. So we have to group this set of information. So for group data, what we just do is that we must have a specific and a consistent interval, okay, that we are going to be using. So if we start from the smallest data value that we have here to the highest. So if you look at it, the smallest here I think is 71 years, and the highest is 102. So we are going to be building our interval on that. So if you have interval from here, that is, look at the interval that we have here. This is from 71 to 75. So from 71 to 75, that is what The interval between them is what? I think 71, 72, 73, 74, 75. Okay, that is 5. So that implies that let's look from 76 to 82. You see that it's going to be 5. So the interval we are building for this golf competition is interval of 5. So from 71 to 75, 76 to 78, until we have 101 to 105. So this one is telling us that all the values that fall between 71 to 75 will be put under this course of 71 to 75. Values that fall from 76 to 78 will be put under 8. A 76 to 78, and that goes on to when you have 101 to 105. So let's just look at the first one here. We have 71 to 75. So that like that from here, you count how many 71 up to 75 that we can have. So we have 1, this 72, 2, okay, 3, okay. Let's look at another one, 75 to 71 to 75. That's what we are concentrating. We have 3 now, right? We have 3 now, okay. We have 4 and we have 5. So that makes that frequency 5. For 76 to 80, we have 6. 81 to 85, we have 8. 86 to 90, we have 3. 91 to 95, we have just 1. So let's quickly check. 91 to 95. 91 to 95. I think let's look at it. Okay, it's just only 95 that we have. No wonder we have 1. So from 96 to 100, we have 3. From 101 to 105, we have 4. 103, this one. 104 to 1023, and another 102. That's also we have 4. Okay, and that's how we can group our frequency. Okay, now the next one here is what we want to look at: pie chart. Pie chart is a type of graph that displays data in circles divided into sector. So the size of the sector is in direct proportional to the frequency of the data. So one thing about pie chart is it actually divides data information and displays it in a circular form, and this is actually being divided into sector. You know the sum of the circle is what? Is 360 degrees. So we calculate based on that using a semicircle, which we call a protractor. Okay, so we are going to be looking at the activities. If you look at this shade here, it's just trying to tell us the number of football, the number of basketball, the number of badminton that we have, the number of hockey, and the number of wickets. Okay, now we have an activities to do here. We are already given a pie chart that is already being illustrated in a circular form. Okay, so we are to what? We have to calculate the number of votes. We have 240 English children were asked to vote for their favorite holiday destination. So calculate the actual number of votes for each destination. So we have the pie chart already. We have 120, 75, 45, 93, and 30. If you have to add all of this, that will give us 360. Okay, and remember that we are told that 240 is the what? Is the sum of the number of students that are actually meant to vote. Okay, so what we need to do here is we divide the degree by 360, which is the sum of the circle, then we multiply by 240, which is the total number of English students. So it's going to, the first one we are picking 120, okay, divided by 360, multiplied by 240 degree. If we do that, we cancel and cancel, then we are going to have 180 degree. Okay, the next one we are picking 75 divided by 360, multiplied by 240 degree. Okay, and that will give us 50 degree. That multiply. Okay, the next one is 45 divided by 360. Okay, multiplied by 240 degree, and that will give us 60. We have 30. Okay, 30 volts. Since we are dealing with the number of votes of students, so we are not supposed to have it in degree. It's supposed to be volts because we are looking at the vote of the students rather. Okay, so for the next one we have 90 degrees divided by 360 multiplied by 240 degree, and that will give us 60 volts. Okay, and the last one there we have 30 degree, okay, divided by 360, okay, multiplied by 240 degree, and that will give us what? That will give us 20 volts. Okay, so by the time we add all of these volts together, we have to get 240 English students that actually vote for that favorite holiday destination. So let's look at the next slide and let's calculate from Okay, this one is telling us that we have the pie, we have the table here. So all we need to do is what? We have to calculate the degrees that will be represented on the graph. on the pie chart. So this time around, we have football to be 35, tennis to be 14, volleyball 10, hockey 6, basketball 5, and others is what? Is 2. So for us to do this, what we just need to multiply is we are multiplying the frequency times 360 divided by 72. So why are we having 72? By the time we add that 7 plus 14 plus 10 plus 6 plus 5 plus 2, we are going to add the total number of 72 students. So we want to get the degree of their favorite sport. So first and foremost, for football, I represent it with R. It's going to be what? That is going to be 360, okay, divided by 72, then multiplied by 35, which is the number of students that actually like football. So by the time we calculate that, we are going to be having that is going to be what? That's going to be 175 degree. Okay, so let's calculate and let's see what we have. So the next one, let's calculate for table tennis. That is going to be 360 divided by 72 multiplied by what? 14. So by the time we multiply 14 times 360 and divide it by 72, we are going to be having 70 degree for tennis. Okay, now for volleyball, we are going to be having 360 divided by 72 multiplied by 10, which is the total number of volleyball, and that is what? That is 50 degree. And for hockey, we are having 360 divided by 72 multiplied by 6, and by the time we calculate that, that's going to give us 30 degree. And for basketball, that is going to be what? 360 divided by 72 multiplied by 6. If we add that, you are going to have 25 degree. And for others, okay, so it's going to be what? 360 divided by 72, okay, multiplied by 2. And by the time we have that, we are going to be having 10 degree. And that gives us the specific degrees that we have for the student favorite sport. So let's quickly put the right hand side to the boxes. By the time we add 35 plus 14 plus 10 plus 5 plus 2, we have what? We have 72. Football will be what? 175 degree, while volleyball is calculated to be what? 50 degrees. So let's check our arrangement. Right, we are cool. So now let's look at the next slide that we have here, which is what? Survey. A survey requires data to be collected, organized, analyzed, and presented. Okay, so we want to perform a survey. What we need to do is we go outside to the field, we get our data. After we have gotten our data, then we organize the data, we analyze it, then we present the solution, and we see the outcome. Okay, now a survey may be carried out for interest sake. Okay, personally, you can just decide to go out there and carry out a survey. So that we have, for example, to find out how many car passes your school in an hour. So we can decide to go outside and count the number of cars that move in front of our school in just an hour. That's an example of a survey. Now let's look at what scatter diagram. Scatter diagram is used to check relationship, that is correlation between two sets of data. How the coordinates of the data set plot on the graph shows the type of relationship between the two data sets. So how the coordinates point, which is on y-axis and on x-axis, how they are being plotted on our graph shows the relationship between any given data set. And this is an illustration of how we plot a scatter diagram. It's just like a point, and that is indicating how the relationship between two different sets. Okay, now we have an example of how a scatter diagram is being drawn here. We are just going to be looking at it. The height centimeter and the masses of 20 children under the age of 5 were recorded. So we have the height for that is for 20 students. The total number of students here are what? 20. So we have to plot a scatter diagram for them. So for the marks, the highest there is what? I think the highest is around, let's check what's the highest for the mass, and that should be around okay, I think I'm saying 19.5 here. So we have 25 to be the range, and for the height we have as much as 40. So we are just trying to check the relationship between the two. When height is 32, okay, the mass is what? The mass is 5.8. So we fix that. When height is 32, the mass is 5.8. Okay, when height is 35, 34, the height is 3.8, and so on and so forth. So the point tends to lie in a diagonal direction from what? From left to the top right. As the height increases, masses increases. If you look at what we have, it's just moving up like this. So as the height is increasing, mass in kg also is increasing. And this one we can now say that since both of them are increasing, there's a positive correlation between height and masses. That is strong relationship between the two data sets. Okay, so we want to look at type of correlation. A strong positive correlation between the two variable x and y. So the point is very close to the line of the best fit. So for a strong positive correlation, as axis increases, that is value on the x-axis, y also increases. So for a weak positive correlation, the points are not tightly packed around the line of the best line. We are going to be using this information to perform these activities. Let's study it after the other, okay? So, but as the x increases as well, y tends to increase, but the points are not what? They are not well packed around the line of the best line fits. Okay, now for strong negative correlation, the point lies close around the line of the best fit. So as s increases, y decreases. So for the first one, which one is strong negative correlation, strong positive correlation, and weak positive correlation for this? I think the first one is what? As y increases, x increases. So that should be strong positive correlation. Now let's look at the second one. Though as x increases, y increases, but there is a scattered point around the line, right? So that should be strong, that should be weak positive correlation. And for the last one, then it said as x increases, x is increasing, y is what? Y is going down. So as this one is moving up, then y is coming down. So that should be strong negative correlation. Let's check our answers. Yes, we are cool. Now let's look at the next type of correlation that we are talking about here. We have weak, okay, weak correlation, weak negative correlation. So the points are tightly identified, okay, so around the line of the best fit. So as s increases, y tends to decrease. That is for weak negative correlation. And when there is no correlation at all, there is no pattern to the way in which the points are aligned. So there is no correlation between the variable x and variable y. So from here, let's look at it. I think it should be weak negative correlation because as s increases, y tends to what? Y tends to decrease, okay? So this is supposed to be for weak correlation. And so definitely this is what? No correlation, because there is no relationship between the variable x and y. Okay, now we are looking at what? Histogram. Histogram displays the frequency of either continuous or discrete data in the form of bars, like bar charts. But the difference between histogram and bar chart is that if you study the bar chart that we presented earlier, there is a space between the bars, the rectangular bars. But for histogram, there is no space in between. So the bars are joined together, and the bars can be varying with width. Okay, so let's look at an example here. The zookeeper measured the length of 32 lizards kept in the reptile section of the zoo. Draw a histogram to show this information. Okay, so we have the information here. It ranges from 0 to 10, and the frequency for 0 is 0. The frequency from 10 to 20 is what? The frequency from 10 to 20 is 0 as well. So the highest value of frequency that we have here is 8. So we start from 1 to 9 here. And for the frequency, we call this upper bound classes. We normally use the upper class boundary to prepare our histogram. So we start with 0, we stop at 100, and that is why we have here. So you see that under 20, that's where the only time we have information. Well, from 20 to 30, we have what? We have just 1, and that's why we see the plot here. From 30 to 40, we have 2, and so on and so forth. So that makes our histogram. Okay, so we are looking at frequency density. For us to calculate frequency density, what we used to do is what? You divide the frequency divided by the class width. That's how we calculate frequency of any given distribution. And how did you calculate your class width? That implies your class interval divided by 2. Okay, so if you have your class interval, the width between your class interval, then you look at it. Let's look at what we have here. From 0 to 1.0, that's just what? That's just 1.0. So look at it, the number between 1.0 to 1.5 is what? Is 0.5. That is 1.5 minus 1.0. The number between 1.5 and 2.0 is what? Is just 0.5. Okay. So from here 2.5 to 2.25, the number is 0.25. 2.5 to 2.25, the interval is 0.25 as well. And from 2.50 to 2.75, the interval is also 0.25. So for us to get the frequency density, what we just need to do is what? We are dividing the class frequency by the class width. So we are plotting frequency density against what? Against the height. Okay, so that's how we do that. Okay, now if you look at it, when we have 6, if you look at the height is 0.1, so we have 0.1. When we have 6 again, the height is what? The height between it should be what? The difference between one is what? 0.115, right? So we have 0.15, that is the highest boundary of the height. Then when we have 8, we have 2.0. When we have 12, we have 2.25. Okay. When we have 20, we have 2.50. Okay. Now when we have 2.7, we have 16. I will come back to 16 here. So that gives us. Now let's look at the past question we have here. We're going to be solving this together. Okay. So first and foremost, let's read out the question. We said one day, Ika records the number of teachers and students who circle the school. So if you look at this, let's prepare the tally. The tally for this one, this is 1, 2, 3, 4, 5. So we have 5 here. Okay, let's count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. That's 20. What? This one is 23. So the total is what? The total is 28. So we have to calculate the percentage of the students who circle alone. So let's look at it. Number of students. Students is what? 23. So we have 23 divided by 28 multiplied by 100. Since we are dealing with percentage, and that will give us 82.1%. Okay. Now we have this table here. It said Mihika record how 120 students from year 1 and year 2 travel to schools. Okay. Each student walk, cycle, and travel by bus. So they said 48 students are in year 1. 48 students in year 1. So that's the total number of students here is what? 48. Okay. 77 students walk. The total number of students that walk is 77. So we have 77 year 2. Okay. 5 students in year 2 circle. 5 students in year 2 circle. So this will be 5. Okay. 36 students travel by bus. 36 travel by bus. That's the total number of students that traveled. 4/9 of students who travel by bus are in year 1. So 4/9 of students who traveled by bus are what? Year 1. So we are going. What is the total number of bus we have? So we have 4/9 multiplied by 36, and that will give us 16. So that implies that 16 students actually travel by bus in year 1. So year 1 we have 16 here. So for this one to make up, it's going to be what? That's going to be 36 minus 16. 36 minus 16, that will give us what? That will give us 20. So what we have here is going to be 20. Okay, so that sorts this out. Okay, now the next thing we need to do is we want to get the total number of students that are here. So what we just need to do is what? 120 subtracted from 36 plus 77. So we subtract 120 minus 36 plus 77, that will give us 7 here. So that implies that the total number of students that circle is what? Is 7. So for us to get total number of students in year 1, what we just need to do, we have what? 7 minus 5, and that will give us what? That is equals to 2. So we have 2 here. Okay. Now we have gotten that. Let's know the number of students that work in year 1. We can easily get that by deducting 48 from 16 plus 2, which is 18. 48 plus 18 minus 48, that will give us 30. So 30 students actually work in year 1. Now, having gotten that this is 77, right? We want to know the number of students that work in year 2, okay? So we can actually say that we have 77 minus 30. 77 minus 30, that will give us what? 47. So we have 47 here. So to get the total number of students in year 2, we add 47 plus 5 plus 20. So if you have that, that should give us what? That will give us 72. And that's how we complete the table. So they said one of the students one of the 120 students is choosing at random. Work out the probability that the student does not travel by bus. So the very first thing is let's look at the probability that the student travel by bus. So how many students actually travel by bus? That is 36. So probability of students traveling by bus, students traveling by bus is what? Is by bus. That's going to be 36 over 120. We have treated probability before in our previous slide. So the probability that the student does not travel by bus is going to be 1 minus probability that student travel by bus, which is 36 divided by 120. So having gotten the LCM is going to be 120 minus 36 divided by 120, and that will give us 84 to 1 divided by 120. First and foremost, what can go in this one? 4 can go in both of them. So we have 21 here, 21, 84 in 21 will give us 4 in 84 will give us 21, and 4 in 120 will give us 30. I think 3 can still go here, okay? So 3 in 21 will give us 7, and 3 in 30 will give us 10. So we have the probability to be 7 over 10. That give us solution to the past question. Let's look at another past question that we have here. Okay, so the next one here is telling us that there are 24 complainants about one of the buses. Okay, so the complainants are the buses is late, the price is too high, and the bus is crowded. So we have the complainant here that we have to do a what? We have to prepare a bisector angle. So what we just need to do is we have to the total number, add this together. If you add this together, that will give us 24, right? So what we have to do here is we are multiplying 10 divided by, for late, 24 multiplied by 360. So if we have that, that will give us 150 degree for lateness. Okay, for price, P, that's going to be 6 divided by 24 multiplied by 360. Okay, if you have that, that's going to give us 90 degree. For crowded, okay, it's going to be 8 divided by 24 multiplied by 360, and that will give us 120. So if you add all of this together, it will give us 360 degrees. So they take us to the end of our class. I want you to subscribe to our channel www.edubbey.com for the full interactive content of this class. Thank you.